All right. In part one of the complex videos, we learned how to add and subtract and multiply, and then we learned the definition. Complex numbers, the imaginary part, I squared equals -1, and I equals the square root of -1. In this video, I'll show you how to divide using something called the conjugate, and then I'll show you how to solve equations. So I'm going to start with the first one. So -1 plus 4i divided by -2 plus 3i. We're going to multiply the top and the bottom by something called the conjugate. When you get into some, or if you get into some higher level math courses, whether here or college or in life, you'll learn a little bit more about the properties of a conjugate. But for the purposes of right now, you just need to know that a conjugate will cancel out the imaginary parts of an expression. So I have -2 plus 3i. The conjugate is -2 minus 3i. So you change the sign that's in the front of the imaginary part so that something will cancel out. So again, -2 plus 3i. So the conjugate is -2 minus 3i. And this is the word that I'm saying, conjugate. So we're going to multiply both the top and the bottom by the conjugate. So on top, we're going to do the box method, distributive property. On the bottom, we're going to do box method, distributive property, and then simplify as we go. There's really no dividing here. So it's really just turns into multiplying. But it is set up like a division problem, kind of like a fraction, but there really isn't any dividing in it. So let us work this out. So I'm going to put some parentheses around here, parentheses around here. So on top, I'm going to do distributive property, and on bottom, I'm going to do the distributive property. If you need to set up two different boxes like we did over here, so if you need to set up two boxes, there's nothing wrong with that. It's going to give us the same answer. So if you need to do a box for the numerator and then do a box for the denominator, that's okay. Nothing wrong with that. But I'm going to do distributive property. So -1 times -2 is 2. -1 times -3i is positive 3i. 4i times -2 is -8i. And 4i times -3i is -12i squared. Draw my line. And I'm going to do the same thing on the bottom. -2 times -2 is 4. -2 times -3i is positive 6i. 3i times -2 is -6i. And 3i times -3i is -9i squared. So I did the distributive property on the top and the bottom. Now we just simplify. So I see a few things that I can simplify. 6i and -6i, this is properties of the conjugate. So this is why they cancel out. So it's going to get rid of the imaginary part there. And I see 2i squares. So I see an I squared here, and I see an I squared here. So instead of this being -12, I know that I squared is -1. -12 times -1 is going to give me positive 12. So this now becomes positive 12. This is -1, so -9 times -1 now becomes positive 9. So on top, if I rewrite, on top I have 2 plus 3i minus 8i plus 12. And in my denominator, I have 4 plus 9. And I got some like terms I can put together on top. 2 plus 12 go together. That gives me 24. I multiply, 2 plus 12 gives me 14. And 3i minus 8i gives me -5i. And on the bottom, 4 plus 9 is 13. If I could simplify this, I would. So if they had a greatest common factor or some number in common to reduce it, I would reduce it. But since it cannot be reduced, you leave it just like this. So this is our final answer. And we just simplified this expression. So to be simplified, you cannot have an imaginary number in the denominator. So we multiply both the top and the bottom by the conjugate. Let's take a look at one more where we multiply by the conjugate. So this is 5 minus 2i. So we're going to multiply 5 plus 2i and 5 plus 2i. So we multiply both the top and bottom by the conjugate. Again, you change the sign that's in front of the imaginary part. Okay. If no number was here, we still will apply the same concept. You will multiply by plus 3i. Okay. So we change the number. If it's negative, make it positive. If it's positive, make it negative. Don't worry about the first number. It's only the number in the middle that's in front of the imaginary part. So I'm going to multiply on top and multiply on the bottom. 4 times 5 is 20. 4 times 2i is 8i. I'm going to do the distributive property on the bottom, but if you need to do box method, nothing wrong with that. 5 times 5 is 25. 5 times 2i is 10i. Negative 2i times 5 is negative 10i. And negative 2i times 2i is negative 4i squared. Notice a beautiful thing here. These are going to cancel out. So if you want to, you really could have just done 5 times 5 and negative 2i times 2i. Same thing over here. We could have just done negative 2 times negative 2 to get 4 and 3i times negative 3i to get negative 9i squared. You only do that if you're multiplying by the conjugate. Other than that, you'll need to multiply all the way out. So I have an I squared here that I need to change out. I squared equals negative 1. So this is negative 4 times negative 1, which becomes positive 4. All it does is going to change your sign. So on top, we have 20 plus 8i. And in my denominator, we got 29. So 25 plus 4, 29, boom. If I could reduce my fraction, I would. Let me see if I can think of something off the top of my head right here. You don't have to write this in your foldable. This is like a little side note if you're wondering what I mean by reducing. Say we have 4 plus 6i over 2. This could be reduced because all of these numbers are divisible by 2. This is divisible by 2, this is divisible by 2, this is divisible by 2. So what I mean is reduce it if you can. I would divide everything by 2 so that I will get 2 plus 3i. So this is a side note. You do not have to write this down. I'm probably going to mark it out so you don't get confused. I just wanted to show you an example of what I mean by if you could reduce it, reduce it. But these that we did right here cannot be reduced. All right, so we've added, we've subtracted, we've multiplied, we've divided. The very last thing that we're going to do is just use I in an equation. So up until this point, if we had an imaginary part of our problem, we would stop and say no real solution, or we just say no solution. But now we can keep going and we can get the imaginary part of our problem. So I got two equations here that we'll take a look at. 5y squared plus 20 equals 0. I want to get y by itself. Subtract 20 from both sides. That's nothing new. Same old, same old. Subtract 20 from both sides. Divide by 5. Again, we're just solving a regular equation. I got negative 4. The opposite of squaring something is to take the square root. So we have y equals plus or minus square root negative 4. Now, up until this point, this was, we need to do the opposite. We need to do opposite. We need the opposite of square was the square root. Now, we can't have a negative inside the square root, so we're going to take out I. Up here in my little bubble, I equals the square root of negative 1. So we're going to factor out an I. So this is going to be y equals plus or minus I square root of 4. And the square root of 4 is 2. So our final answer, y equals plus or minus 2i. That's our final answer. So we subtracted 20 from both sides. We did all this old stuff. We got it all the way down to the part where we have a negative underneath the square root. Up until this point, we would stop and say, no real solution, no solution. But now we can keep going because we know that I is equal to the square root of negative 1. So I factor out an I. I just took out the negative. It became I in the front. And the square root of 4 is 2. But we don't say I2. We say 2i. Just like we say 2x or 3x, we say 3i. So that's my answer. And last one, I have an equation over here that I can solve. If I were to graph this, it would not cross the x-axis. Again, if I were to graph this, it would not cross the x-axis because it has some imaginary solutions in there. If I try to factor it, it can't be factored. If I try to take the square root of it, I cannot take the square root of it. So my other options are to complete the square or do quadratic formula. Since we just took a look at quadratic formula, I'm going to use this time to do quadratic formula with this one to kind of refresh our memory. So A is 2, B is 4, C is 3. Okay. Quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. So I'm doing the quadratic formula that we just learned, and I'm going to show you that underneath the square root, we're going to have a negative number, and I'm going to show you how to take the I out of that. Just like we did over here, it's going to get down to a point where we have a negative in the middle. So I'm going to show you how to get rid of that and just put I in front. So we're going to take these numbers, the 2, the 4, the 3. We're going to take these numbers and substitute them into the quadratic formula. So that's going to give me negative b plus or minus square root of b squared minus 4 times a times c, and that is all over 2a. So I took 4, plugged it in, took 4, plugged it in. A is 2, C was 3, I had another A, so I took all my numbers and I substituted those into the quadratic formula. Now I can use my calculator, Desmos, whatever the case may be. If I substitute all this in, it's going to give me a negative number, which we'll have to factor out. So when I use the calculator, it gives me negative 4 plus or minus the square root of negative 8. All over 2 times 2 is 4. Now, can't have a negative on the inside, so we're going to factor out I. So now I have negative 4 plus or minus I square root 8 all over 4. We're about 90% done with the problem. The rest of the problem is just simplifying, so I need to do a factor tree with 8. So we're going to do a factor tree with 8. I'm going to come up here and do a factor tree. I got 2 and 4, 2 and 2. So 8 becomes 2 square roots of 2. So I did a factor tree with 8. So 8 breaks into 2 times 4. 4 breaks into 2 times 2. Pairs, you're looking for 2 of the same number. Pairs go on the outside, everything else goes on the inside. So I can make a substitution and change this to be this up here. So now my problem looks like negative 4 plus or minus 2i square root of 2 over 4. So I made a substitution. I'm going to circle that in the blue. Square root of 8 is the same as square root of negative 8 is the same as 2i square root of 2. So I did a factor tree, which is up here in the blue, prime numbers, and I replaced 8 with 2 square roots of 2. And then I brought my I down. And last up, finally, this was definitely a long problem. I can reduce everything. Negative 4, 2, and 4 are all divisible by 2. So I can simplify this. So I can divide this by 2. I can divide this by 2. And I can divide 4 by 2. One additional step, if we wanted to, I can separate this and make it be a fraction, or we can leave it just like this. All right, so now we know all about complex numbers. I squared equals negative 1. I equals the square root of negative 1. So now we won't stop and say no solution. We'll keep working on things until we get the imaginary part.